morning, students. Myself, Dr. Eustace Russell, working as assistant professor in the Department of Mechatronics Engineering at Sri Muthukumaran Institute of Technology. So far, we are discussing the subject called engineering mechanics, and in the unit 1, the statics of particles, we completed the first two parts in successful manner. Now, today we are going to discuss about some few topics that is coming under part 3. Kindly go through it. The subject code is ME25Z C02. In today's class, we are going to see about addition of concurrent forces in space. Last class, we have seen the roller container problem, resolution of forces method, equilibrium of condition we have applied. The same variety of problem, how we will solve in the vector method also. That is a vector approach. So that also important. The first thing, we must know what is vector, free vector, whose action is not confined to or associated with a unique line in space. Example, movement of the body within rotation. Sliding vector has a unique line of action in space, but not a unique point of application. External force on a rigid body. Principle of transferability. Then in rigid body mechanism also we can implement it. So the first thing is the action is not confined or to associated with a unique line in space. That is free vector. In this case, unique line of action in space should be taken into account. That is important. Fixed vector, for which a unique point of application is specified. Action of a body on deformable body. Action of a force on a deformable body. So when you are applying some force on a body, there will be some deformation will happen. That is a fixed vector one. Now already we have seen some basic laws in the first part also. This is the continuation of that. Again we are going to see some of the law apart from that. Vector addition procedure for analysis. Now you are going to see various methods are there. The method is not an important one. The finally what method we are using, finally you are getting the answer or not, that is important. Any method we can use, but final answer will be same. It's not going to change at all. Parallelogram law will be there, algebraic solution we are using, trigonometry, geometry also we are using. Now we will see one by one. What is that means? Parallelogram law, first of all, that is graphical one. Resultant force, diagonal components, that is sides of parallelogram. Another one is algebraic solution using the coordinate system. Trigonometry, that is geometry. Resultant force and the components from the law of cosines and the law of sines. So in the right hand side of the slide, we can see that one cosine law is written there. That is C equal to a square plus b square minus 2ab cos c. That is square root. This type of problem you might have studied in 11th standard, I think so, 11th, 12th, maybe in school days. You have heard about the law called cosine law. And sine law is nothing but a by sine a, b by sine b, c by sine c. So these are the various laws of formulas we are using. By that also we can find the answers. Now that is the first is a vector form. We can see one of the basic example. See, one force is there inclined at an angle of some angle theta. Now we can write in two coordinates, that is I cap and j cap, two vectors, unit vectors I and j. So that's why v is common term. So cos theta I plus sin theta j. The similar case, a right angle method. In this kind, they won't give any angle. At that point, what you have to do, that is important. How you are going to find. Angle is not given means direct approach. We can write 4 along x-axis, therefore 4i, 3 along y-axis, therefore 3j, adding that to j, I and j component, divided by square root of these two values. Squaring those values and add it and then take the square root. Then what is this method means? You have the two endpoints. For example, here we can take x1, y1, that side x2, y2. So x2 minus x1, that is 9 minus 2, I component, plus 6 minus 3, that is y component we are taking as j. then taking the square root. What is the denominator? What you are getting? Just take a square and add it, and finally take the square root. You will get the answer. Now this is one problem, one basic problem and important problem also. Determine the x and y scalar components of f1, f2 and f3 acting at a point A on the A of the bracket. Now first give some time to observe the sketch properly, students, because noting the dimension, what is the angle, wherever it is acting, everything you must know. First of all, dimension is very very important. How many forces are there? F1, F2, F3, clear. Then what are the distances along x, y? Distance is very very important. Then one triangle, for finding the angle they have given, the method already we have used, that is tan ratio. We have to tan angle we have to use, opposite side by adjacent side we can use for finding the angle. Now in the right hand side we split up in the components. F1 is split up into two components, right? That is 35, that is 600 cos 35, 600 sin 35. You'll get like that. Then 500 we have to find the angle of that one, then only we can note down that. Then 800, 800 is nothing but the alpha is acting over there. Then finally how much you have to find, that is important one. That alpha is not given, that is one important note. So here it is, what is along y axis? 0.3 plus 0.1, that is 0.4 meter. And here also we can see the total is, what is total? 0.2. So half is 0.2 means remaining will also be 0.2 meter. Then using the calculation, the same procedure we are using, the x components, y components they have done separately. Then alpha equal to tan inverse of 0.2 by 0.4. We will get the value as 26.6 degree. Then alternative solution for the previous problem. In the vector method we have to do. What you have to do means, as I told in the previous slide, vector form, the first rule we applied, v cos I, v cos v sin theta j, like that we have to use here also. That is f1. Again the unit vector lambda formula we have to utilize here. Cos 35 I, f1 is nothing but 600 only. F600 should be taken common. Divided by what is the denominator? Just square the value, then add it and take the square root. Again the same thing, what you are doing, exactly same, but here it is different. F2, what we can do? 4, 3 is given, 4 along x-axis, therefore minus. Why it is minus? Because it is acting in the right hand side, so it is minus. Then 3 will be positive only, it is upward force, so plus 3j. Then taking the common value 500, you will get the value F2x is equal to 400 Newton, F2y equal to 300 Newton. Alternate solution, again a continuation of that one. This AB, what you have to do? AB is the distance. How much distance that is given, that is important over there. 0.2 I minus 0.4 J. Then taking the square root of that one. How much we are going to take, that is important one. So it is 0.2 and the 0.4 is acting in the downward direction, therefore minus. Then taking the square root and apply this formula, F3 AB vector by AB modulus, taking the square root for modulus. Then you will get 358 for F3x and F3y 716 Newton. Another one important problem, two forces act on a bolt at A as shown in figure, determine the resultant. First of all, what formula we are using? Trigonometry solution, apply the triangular rule. Okay, this formula is very easy. We can apply that. The two different values are given. Then we can go for the law of cosines. The formula already we discussed in the previous slides. Directly apply the formula. R square is equal to P square plus Q square minus 2PQ cos, that is angle whatever it may be, it is beta. Okay students. Now finally you will just substitute and you will getting 97.73 Newton. Then applying, what you are going to apply? Applying the similar procedure, the law of sines, sin A by Q, sin V by R. Using the formulas, using the relationship, you will get the values. That is sin V Q by R, cross multiply, then finally get the values one by one. So kindly make a note of that. We are finding the alpha. A, we are in the diagram, you can see why we are adding 20 plus A, right? We are adding with that angle to get the final answer alpha, that is 35.04 degree. Kindly make a note, all are important steps. Finding the angle is very much important. Then components of force. Again this method, R equal to P minus, another one alternate method we are going to use here. Then outside the 40 cos 20 I sin 20 J, then you are getting 37.58 I plus 43.68 J. Q also similar method. And finally using subtract it and get the value 97.72. Alpha is equal to 35.03. So these are the two references which I used for preparing this content. Kindly go through the reference and go through the video thoroughly. Thank you, students. Thank you for the kind attention for seeing this lecture. So we will see in the upcoming video lecture, that is part 4 of unit 1. Please subscribe the channel, like the video and share to your friends. Thank you.